Okay, so here we are. This is, hi Laura. This is AP Chemistry.
Is she really on the
Say hi everybody.
Yeah.
No, she's not really on the other end. We're just recording this, and
Oh, I was going to say, I think
which I guess means if you wanted to watch this lecture again, like that's likely, you could get on the website and look at it. Well, I'll give you more details next time as to exactly where it is and where you find it. But what we're going to do is we're going to solve this two quick questions. The questions in question are, for this reaction, cadmium sulfide plus iodine plus 2 hydrochloric acid makes cadmium chloride, hydroiodic acid, and elemental sulfur. Determine the oxidation state of each element in this reaction and identify the oxidizing agent and reducing agent. Well, it's useful if we remember what those things are. So, oxidation state, what does it mean?
the ability to be oxidized or reduced.
Yeah, ability to be oxidized or reduced. It's kind of related to charge, but kind of not. Basically, it's just something that we use to identify what's being oxidized, what's being reduced. So, that brings up another question. What does oxidation mean? An increase in charge. And if something increases in charge, what happens to the number of electrons it has? Has to lose electrons. Okay, so what is reduction? Decrease or reduction in charge. And reduction in charge is caused by a gain of electrons. Good. Okay. And this is kind of for your benefit too, Natasha, since we're kind of covering stuff we didn't do last time. Okay, so what were the rules for determining oxidation states? Well, there were several of them. Pure elements have an oxidation state of 0. Monatomic ions have an oxidation state of equal to their charge. Good. Hydrogen has an oxidation state of +1 in covalent compounds. Or what if it's the -1 if it shows up as hydride? Okay. Oxygen has an oxidation state of
In all compounds, unless it is present as peroxide, then it is negative.
-2 in all compounds unless it's peroxide, in which case it's -1. And what about other elements?
Fluorine is negative.
Fluorine's always -1. Everything else we pretty much have to deduce by doing all the other things first. Okay? So let's do this. Cadmium sulfide, do we know the oxidation states here?
Yes.
What's cadmium? +2, because cadmium ion is always 2+. Sulfide, you already know, is -2. Iodine, 0. This is a pure element. HCl. It's got to be +1. Chloride is -1 as a result. Okay. Cadmium. Once again, that's +2. Chloride is -1.
But there's 2 of them.
There's 2 of them, so it's
So it equals out, but it's minus.
-1. This is per atom, by the way. Hydrogen. +1. Iodine. -1. Because this is iodide, not iodine. And sulfur. 0 because it's a pure element. Okay. So, those are the oxidation states. +2 for cadmium, -2 for sulfur there, iodine, blah, blah, blah. Now, what is the oxidizing agent? Well, what do we know about the oxidizing agent?
It causes something else.
It causes something else to be oxidized, which means that it is reduced. What do we have up here that is reduced in charge?
Sulfide.
Nope. Iodine. Iodine. Iodine is reduced to iodide. Okay? So, the oxidizing agent is iodine. And let's be a little more specific here. Let's say the oxidizing agent is I2. It's reduced to okay. And what is the reducing agent? The reducing agent is whatever is oxidized. What is oxidized in this equation?
Sulfur.
Sulfur is close.
Sulfide.
Sulfide is better. Sulfide, S2 minus, is oxidized to sulfur. Okay? Are we all right with those?
Now, what about iodide?
What about iodide?
Well, because it's 0 and then it goes to -1. So why doesn't that? Oh, wait, sorry.
That means it's reduced.
Okay, yeah, sorry. That's okay.
Okay?
That didn't work.
All right. Now, the oxidation states of everything else in here remains the same, right? Okay. So, this is a good first step towards solving oxidation reduction problems. Have to be able to identify the oxidation states of the various things and identify what's being oxidized, what's being reduced. Now, what's the use in being able to do that? We'll go through that step by step. So this is Redox 101. Okay.
Oh my gosh, I get it!
Last I saw, this was still available on Cafe Press.
I could not figure out why there was a red ox.
Now you know.
Redox. I'm like, I see it now.
All right, so
Stop wearing this shirt tomorrow.
here is a problem we are going to learn how to solve together.
Oh my.
Balance the following reaction which takes place in an acidic solution.
What?
Now, if you're looking at that, your initial thought is, what in the world is going on here?
Yeah.
Because, okay, you've got chlorine, but you've got 2 over here, you've got 2 chromium over there, but just 1 over here, and you've got oxygen in there too. How the heck are we going to solve that?
Water and
Well, the first thing we're going to do is we're going to identify the oxidizing agent and the reducing agent. We're going to figure out what's oxidized, what's reduced, and we're going to write 2 half reactions. Okay? So, oxidation states, if you will, please. First of all, this one. What's the oxidation state of oxygen? -2. Now, what about chromium? So here's how we would reason through this. The total charge on, what's this ion called? Cr2O7 with a 2- charge is called?
Dichromate.
Dichromate. Good. What oxidation state is chromium in? Well, the total ion together has a 2- charge. That means everything together has to add up to 2-. So we have 7 oxygens, each with a -2 charge. What's the total negative charge just due to the oxygen? -14. What do we have to do to make the total thing overall come down to -2? +12. Okay? Where's the plus charge going to come from? The chromium, and there are 2 of them, which means each chromium must be +6. The state of chromium, oxidation state of chromium, is +6. Okay? That's really high, by the way. We'll get to that. Chloride ion.
How you doing?
Oh, hang on just a second.